I'll turn my lights on in just a moment. I'm just a little behind. I was so on time last week. I've just been like deep in the weeds of yoto hacking and I can't get it working and I don't know why. So I'm gonna get the lights turned on. Turn the lights on in here. I have two like lights right here to light me up. There's one. We'll get started in just a moment. This one doesn't like to stay connected, so I always have to flick it. How's everybody doing? Looks like we got going here. Pause preview. This one's paused too. Everything working on other folks' end. DCD says they're doing okay. That's good. It is bright in here today. All right, hopefully that's a little better. Hopefully you can hear me okay. Hello, Retired Wizard and DCD. I saw Beata and Patches O'Houlihan. How goes it? Welcome, welcome, welcome. Tired, but I just put on the stew pot. It will be delicious. That does sound good. That's a good winter thing to eat. I do like a good stew. We have a kind of a tradition of doing what we call a solstice stew, which is a beef stew, but we do it around solstice. It's a good thing to do in the middle of winter. Let's see. All right, I guess we'll get started. I did get started late, so hopefully folks will join us. Hello, everybody. My name is Scott. I go by Tan Newt online, and this is a deep dive. Me or Tim tend to do deep dives, and this is a chance for us to talk about what we've been working on and get into the weeds of it all. Answer any questions, so if folks have questions, feel free to drop those in the chat. We've got the Discord chat in the middle here, and we've got the YouTube chat below it. You can join the Discord by going to adafru.it/discord. We're in the live broadcast channel, although during the week I'm usually in the CircuitPython dev channel more than anything else. I work on CircuitPython, which is a version of Python designed for little tiny computers called microcontrollers. And the goal with CircuitPython is to make things super accessible so you can program devices to make to do all sorts of things for the projects that you want to do. I'm funded by Adafruit to do this. So Adafruit is an open source hardware and software company based out of New York City. They do lots of open source stuff. I work on the open source software side for them, but they have all sorts of little open source hardware that you can purchase from adafruit.com. That supports them. They pay me. It's great. They're great to work with. It's been 9 years? 9 years for me? I guess it'll be 10 years in August that I've worked with Adafruit, so it's been pretty wild. I can't imagine that, but it's been a pleasure. So, Patches O'Houlihan says that's the 21st, right? Yes, the solstice is December 21st usually. It varies around the day, but it was the 21st this year. December 21st is the solstice. So we made a solstice stew for that, and it was yummy. My wife is a very good cook. She can taste better than I am, and she actually tastes her food. Two critical things to cooking. The Shibu says, what happened to the change your job every 3 years advice for software engineers? I think that went away with all of the layoffs of big tech did. I think for me it also, well, I told myself that I would only work at Google for 3 to 5 years, and it was 6 years before I left. Nolan8495 says, I was wondering what you're working on right now. Good segue. I've been working on hacking the Yoto player, which are these little players. Here's the shell of it. So it's this little player. You actually hold it like this. So it's two knobs that you can turn and stuff, and it's got a speaker. And they don't tell you it's a display, but it's a display. But it shows like little like bitmap graphics on here on the display here. This is the mini version. I have the big version too. Here's the shell for the big version, part of the shell. So I've been taking them apart, trying to get CircuitPython running on them. They are ESP32s. And I've been collabing with Liz, Blitz City DIY. She's done, to some degree, made more progress than I have. But I got it running, and I got the eMMC working, so the storage working. But I did not get, I've been trying to get the display working, and I can't quite figure it out, how to get the display working correctly. So I've been poking on that, and then my youngest, my daughter, got sick on Wednesday, or she came home Tuesday from daycare, and so she was home on Wednesday, so I was home with her. And then yesterday, my wife took the day off, so she watched her, and then I watched her in the morning. So some of my week, yeah, that's pretty sick still. I know. I'm like, I'm gonna figure this out. So I actually ordered. Maybe I should just go to my bench cam. Let's talk about this, because and if anybody knows before, I'm totally down to go on tangents. So here's my bench cam. I'm just gonna move it because it's not actually showing what I've been doing. But over here, I know it's kind of far away, and I should have used the hover cam. But what I've got, this is the board for the Mini, and this is a PCbite. So it's got these like magnetic like holder things that can go on this, like, it's a steel base with a cover on it, so it can hold it there. And then they've got these like little dangly, you can't see it very well, there's a tip on the bottom there that's spring loaded that you can put on the PCBs, and it kind of holds it there for you. And I've been trying to use that to do everything I want, and I just don't have enough of them. So I think on Monday, which is actually a holiday, I think I get more, which should help me figure it out next week. And then this is the way these Yoto player works, is that they come with these cards, and you can buy like cards for playing Frozen and Hamilton and stuff, and they're just RFID cards that like have some key on them so that they can download the appropriate audio. But it's a really interesting interface for kids to pick the music they want to listen to by switching which card is in the player. So I've been trying to do that. So DCD says, what debug tools do you have for the Yoto player? I searched online for some background. What resources did you use? So Liz has been documenting it better. If you go to adafruit-playground.com, you'll see Liz. So we both tore it down. We both took pictures of everything on the board, and tried to identify all the different chips that we saw. So we could figure out that like it's got eMMC, and it's like 32 gigs, and there's this ESP32, there's a DAC, there's a IO expanders, that sort of thing. So we figured all that out, and then I've just been probing it really. So these probes that I showed are attached to my Salier, and I can go back and forth between running CircuitPython and running their firmware. So the first thing I did before I flashed CircuitPython is I dumped the firmware off of it. And I was able to read it out, and I can put it back if I want to like inspect the signals as it works. One of the challenges has been that on the mini board, which is simpler, the big board has 2 IO expanders. The small one has 1, but it's a BGA, so it's actually quite hard for me to get access. Like, I can't probe the output signals of the IO expander itself because it's BGA. They're like underneath. So I'm like I was inspecting, I captured all the I2C traffic, and then I was like trying to guess at like which IO expander pins do that. The reason it's taken me all week is that they put at least, I think they put both chip select and the DC pins for the display on the IO expander, which is an interesting way. Like there's not that many pins on the ESP32, especially because they're using 4 bits to the eMMC so they can load quickly enough. So yeah, it's been that and trial and error. And yeah, just trying to use the Salier to understand what signals are. And like, I was happy I got the eMMC working. So there's like one particular, like I had to do some IO expander stuff to get the eMMC working, like to take it out of reset. But then I was able to just load it up and it worked. So like we had the bulk storage working, which is good. So yeah, just I'm not super methodical, and I guess we'll talk about that a little bit later. But I just wrote this, like I was like, I got to figure out what these test points are. So I like drew where the test points are, loaded the stock firmware, kind of inspected what it was and what I thought each pin was. And the like DC CS pattern that shows up there on the stock firmware makes a lot of sense, but my firmware doesn't. So I'm like trying to figure out, like my IO expander code is not working quite right. But it's potentially really exciting because I've restructured the internals of CircuitPython so that we can have native IO expander support. So that like the 4-wire bus, which is the bus used for the display, can like have chip select either on a native digital in-out or an IO expander pin, which is like the equivalent of a digital in-out. So like we're getting something out of it. Hi, Jono. It's just not working quite right. I was just thinking what I need to do is I need to capture, and I'll probably do this next week when I have like some more probes, but I need to capture the I2C lines and the 2 pins, the CS and DC pins that I care about, so that I can straight up just read I2C transactions along with what those 2 pins are doing. Because it might be a timing, I was thinking about this, it might be a timing thing where like my code is not waiting for I2C to actually finish, for example. But it'd be really cool to get this device going. Liz got the headphone output working, but not the speaker yet. So the speaker is kind of the tough thing. But she's made like libraries for the NFC reader, and like the power chip too. So it's like, I think we're gonna do it. It's just been kind of a learning experience. Any questions before I move on to CircuitPython? CircuitPython year, I think is what I'm going to start calling it. I don't see. Oh, Nolan8495 says, would I be interested in funding? Well, I am funded. I am paid by Adafruit to do all this stuff. I don't use Twitter because I disagree with the person that owns it. But around the internet, I'm Tannewt, Tannewt. I don't post a lot on like Blue Sky. But you can find me on the Discord, and you can find Adafruit. Yeah, I'll pull up. Yeah, so this is what, let me go to the desktop. So this is Liz's stuff. I just saw this one. I was like, oh, of course. Like, Liz made a nice like interface to like load the code and stuff. I really should do this too. I've been meaning to I need to go to the makerspace to solder a bunch of stuff, so I should probably do something like this. But I have dreams of like figuring it out and then putting it all together and being able to use it. And it's just not quite there yet. So Liz has done this to be able to load the code. So this is the board for the Mini. And then this is Liz's teardown. And she went even further. Like there's like above here, you can't see my mouse. So this is the MMC, and then this is the IO expander. But there's this like holder. You can see the outline drawn here. It's a holder for the display. And she like clipped it all the way off, and I've like kind of not wanted to do that. This is the flat connector for the display. So she got better pictures, and then has started to document all the pins, but I actually did also some of this. The ones that she doesn't have are like the MMC, so the memory stuff is not on here, but it's fine. But yeah, she does a really nice job of like highlighting like what's what, and RFID reader, real-time clock, the eMMC, I2S DAC, that's at least used for headphones. So like she's using this to document all the different parts. I kind of want to get a second one because it does feel really doable. It's just I've got to figure out why my IO expander stuff doesn't work. But the web workflow works quite well. I was using that. Once you get your credentials in, it's like quite nice, which is great. So yeah, Liz has been doing really nice work, and she actually posted the factory firmware too. If you want to follow along or have a need for a mini audio player, this is gonna be it's gonna be cool. Like I have 2 kids, right? So I'm hoping to be able to use those for them. And it's actually like kind of hard to have, like if they have headphones, what do you plug them into? So this is a good answer to that. So yeah, that's been taking my time when I've been at my desk. The other thing I did this week, I've been thinking about, is CircuitPython 2026. So if you don't know, every start of the year is when I like to reflect on the past year and think about what I want to do in the coming year. And so I wanted to post mine by now so I could talk about it. And I posted it just like an hour or 2 ago, drafted it earlier in the week. So I want to talk about that. Yeah, I'll talk about that, and then I'll go over the other ones that I got from folks. And I just got an email from Foamyguy, who also does deep dives. He just posted his too. But I'll just start with mine since I was talking about it. So it was interesting to me thinking about what I want to do. For one, I looked last week when I read over my CircuitPython 2025. It was like, do Zephyr, and I was like, oh yeah, I like still want to do that. So thinking about the coming year, I was like, well, I actually want to do a lot of the same thing that I wanted to do before. Like that hasn't changed, but what has changed is how I'm doing it. So this is going to be my take on agentic coding LLM stuff. So if you don't know, and I think actually later I'll try to show this, but we'll see. But I've been experimenting with things like Claude Code, and it's quite awesome when you use it for, as I talk about in the post, tedious things. And there are plenty of tedious things that that I do when I'm developing CircuitPython. For example, if I'm in the Zephyr port and I'm adding a new module that I'm supporting, right? So I'm implementing Common HAL. Like Claude Code is quite good if I could say, hey, I want to add I2C support or SPI support to the Zephyr thing, copy the way that bus.io I2C works in other ports. And it can do that discovery, and it will create all the new files, and underneath Common HAL, it'll have the like headers on it, and get me a first draft really quickly, which is just wild, because it would be the sort of thing that would take me a while to do. Like I never thought that the value of a coder is how fast you can type and do things like that. but LLMs, so large language models tied into these coding agents, are just like, if you do code, you should really try it, because it doesn't always work and it does things wrong, but like if it gets close enough, it can save you a lot of time. Hello, Youssef. So that's what I talk about here, is that like I'm trying, especially now that I'm like not working part-time, watching my daughter, watching my youngest, like I really do want to like try to get Claude Code into my thinking about what I'm working on. And then what I also talk about is that, yeah, you can go ahead and answer questions and I'll get interrupted, and that's fine. But I've told people a lot, like coming from CircuitPython to people that are doing Arduino or C, I will say like, look, like it's really quick to try Python for your project. You should just try it. If it works out, great, you saved yourself a bunch of time. If not, you can still go do the C because it's going to take you a while, right? And that's been my argument. That is now my argument for trying something like Claude as well. Hi, Johnny. Is that like if you're doing something like adding something to CircuitPython core, and it's been done kind of the same way, or just whatever new task you're starting, you should just try to see if Claude Code can do it, because it might get you like pretty close to where you need to go. And it's especially valuable if you have to change a lot of things or if you want to refactor something. So one thing I did with, one example of that is when I was introducing this IO expander stuff, I said like, oh, like I actually want to like have this type def for error numbers so that I can know when a function is going to return an error number. And so I just said like, find all the places that these are returned and make sure they're all negated, and then change the type so that we know that they're NP error number. And it did that. It can find the places, it can do its best guess at doing it. So what I was finding is that I had Claude Code open and I had Sublime Merge open. So I didn't even have my text editor open. I was just like using Sublime Merge as my way to see what the Claude Code was changing. Retired Wizard says, I find it helps me get over the initial hurdles to starting a project. Yeah, I think of it as a first draft. So it's really good at giving you a first draft. And then what I talk about later is like, how do you make sure it works? As you know, I call you out, Retired Wizard, for finding that my pathlib stuff didn't work. So I'm not very rigorous in testing, and that's like, I think that's my goal for the year, is like do more LLM stuff and figure out how to be more rigorous in my testing that I do, so that I know that I'm like doing it the right way. Okay, I'm gonna take a pause on that and take a look at what Youssef is asking. I'm developing a library more like a stack of graphics libraries. The question is it possible to create a binding for those libraries for MCU Pythons? I barely have any knowledge on Python interpreters and microcontrollers. Usually I use FFI, but that doesn't exist for sure on CircuitPython, MicroPython. Are you writing in C? What are your libraries written in? In CircuitPython and MicroPython, the technique is the same, but in CircuitPython, we're more rigorous on how we structure it. So you can see this browser. In the CircuitPython source code, if you just go to shared bindings, the libraries are in pure C11. Yeah, so the technique for going from Python to C is the same in MicroPython as it is in CircuitPython. But we usually do that in shared bindings, unless you can also have bindings that are port specific. The implementation relies on barely any platform specific functions. Yes, so shared bindings is the directory where, and the folder names are modules. And then within the folder, we have like classes plus init. So what you would want to do is you'd want to create a new shared bindings folder for your module or modules. You could have multiple of them. And that is the layer that only goes from, I should have just used that. This is the layer that adapts from Python land. So Python under the hood are structs, and there's like helpers to get from structs or packed values into like C types. So make new is a little unique, but you'll see that you just get the number of arguments, the number of keyword args, and then like a list of NP obj keys. And then there's ways to convert those arguments to C types. And the way that we structure it in CircuitPython, this is shared bindings because these bindings are shared across ports, even if the implementation is actually shared as well. But you'll see these are Python-style docs. And then this is kind of like all the boilerplate in order, like this is setting up the value property. So under the hood, a property, this is only a getter, so it just has the get implementation. And then in CircuitPython, we designate the layer underneath this, the C layer, common HAL. Common HAL is the layer that usually each individual port will implement. But in your case, and in some other cases, we also have shared modules, what we ended up calling it. And again, this is the same idea where you have shared module, and here's all of these things that are implemented kind of in a cross-port way. So like bitmap support for display I/O is an example. And so this is where you get your common HAL implementations. The declarations go in the shared bindings header, but the shared module is where the actual implementation goes. So I would highly recommend trying an LLM on this sort of task because there's so much code just in here that it can use as an example. So you could say, you're doing something graphics oriented. So like find an existing thing that's kind of like what you want to do. Say, make this new module, it's called foo, and use such and such as an example. And when you say use such and such as an example, it would say, well, okay, let me basically grep for that in the code base and get that as my context. And then I will generate these new files. And it's quite good. I've used it to do this. Like the IO expander classes that I've added, like I used it to do that. And it's smart enough mostly smart enough to figure out how to get it into the build system too. So yeah, use an LLM, it'll get you a long way. If you can give it your source, it'll take a stab at like linking the two together. It's not going to be perfect, but yeah. I think I kind of got it, but the thing is, how would I publish my binding? So MicroPython does have a way of having what they call native modules. And I think we have it on in like one board, but basically where you could call C code from another file, but it's quite finicky, frankly, because it does some sort of like linking style things. What you'd want to do is what I would encourage you to do is just merge it into CircuitPython. So you would have your library, and we have third-party libraries snapshotted in lib, I think. So yeah, basically you would add it to CircuitPython. And it's not going to go on every board, but you would have to figure out, like if you're doing graphic stuff, maybe you want to pick a board that has graphicsy things on it, and then you'd be able to do that. So you could link to your C library in lib, which is as a submodule, and then you would write shared bindings and shared module in CircuitPython itself and PR it up. And we'd say, well, it doesn't fit on all this stuff, we'll turn it off on the stuff that doesn't fit, or like, here's how we integrate it into the existing display stuff, that sort of thing. And like, you could even do it completely separate from the existing display stuff, but yeah. We're open to it. We definitely have some size constraints, especially on the older stuff like SAMD 21s and 51s. But yeah, we're open to having things like, if we see the Eve, like there's an Eve module here, like that's like somebody added that for their particular like kind of graphic setup thing. Any other questions on that? Merging into CircuitPython is a good idea, but what about maintenance? My libraries are new and the development will be a bit rapid for the first couple of days for sure. I mean, it's, if you're talking days, like next week, like, if you were wanting to co-evolve them, like work on them both at the same time, like you can work within a submodule and modify it there. But you wouldn't want to check it in until you kind of thought you were ready. But you could get it working on CircuitPython for yourself personally, like pretty quick. And then like maintenance-wise, it would be on you, unless we were like, we have to adopt this thing. But things are kind of like, it would be up to you to maintain it. Like we would have a submodule in CircuitPython, and we're not going to update that submodule on our own, unless like the way that Adafruit prioritization kind of works is that we have to like, we support Adafruit products, and so that's our top priority. But if somebody else wants to come along and get submerged in, like I'm more than happy to review it. It's just that like I'm not going to fix things, but I won't like automatically update it. Like I'm not going to do that work, but I'm happy to like enable you to do that, or anybody else. And the best resource for that is on the Discord. We have a CircuitPython dev channel. So if you're like trying to get CircuitPython building, that's the way to do it. And you'll want to pick a platform that you're going to experiment on too. But yeah, should generally be around. I don't have any big trips planned. It's just a little, my life is a little uncertain just in terms of joining kids. Sick kids. I saw you write joining and I said that instead of, yeah. Sick kids make it a little less reliable that I'll be in the office, but I'm around and there's other folks on the Discord that are helpful too. Okay, so going back to CircuitPython 2026. So this is my pitch for like, if you've been hesitant about LLMs, you should give it a shot. It's actually quite good for exactly what Yusuf is talking about, which is like laying the foundation for hacking on CircuitPython, adding a module. It's like great for that. But the caveat is that you do need to test your code. You need to test it. Like LLMs are really good at generating things that look plausible. But if you don't test them, you don't actually know that they work. And this is my issue with people using LLMs for support, is that they say like, oh, Google said this. And it's like, that's actually not helpful at all, because like the person that's on the support forum can ask Google that as well. Like the value in LLMs is that it can generate something that might work quicker, but like it's still on you to determine if it actually works the way that you think it should work. And because we can generate more code and change code more quickly, like we need to, hello the Darsh, welcome to Discord. We also need to like having a better test regimen is going to help. It's going to help things, and I want to do better about that. Come up with better ways of like testing things, and yeah, so that's kind of my personal goal. So that's like half of my CircuitPython 2026, and then the other half is actually I think that we can use LLMs in our workflows for writing Python code. I use Arch, by the way. I use Arch too. I don't know if that's obvious or not. Yes, so I don't think that we're going to add a workflow to the core of CircuitPython like we did web workflow and BLE and USB. I think what we're going to do is I would like to experiment with doing an app on a phone that uses Bluetooth Low Energy or Wi-Fi to have an LLM generate code, load it on, and then get the output back and figure out. Oh, and I realized that my YouTube. Oh, I'm looking at the wrong. Looks right. But like using LLMs to write code on your phone could be really cool. I've always like tried to get this like code from your phone thing working, and it's just doesn't work out. But I think because coding with LLMs is more reading and talking, I think it'd be a lot more pleasant than typing. So that's another thing I'm really keen on trying. I don't know when I'm going to do it, but I know I'll use LLMs to try it. OTA, it's not quite OTA. It's just like you're Bluetooth connected to your device and you can just load it. It's not quite like what I would think of as OTA, where you have like some central server that's orchestrating it. So yeah, if you haven't tried it, do try it. Here's a few links to folks that I follow to like kind of see what the latest things to try is. And the Oxide and Friends podcast, like the last one, episode 2 of the season, like it's really interesting because they're talking about it. They talk about using LLMs because it can boost your ability to change things. You can do refactorings that you wouldn't have done before, because LLMs are really good at applying a pattern across a large set of the data, or like a large code base. In fact, I made myself a work tree that's CircuitPython-YOLO, which is like what you only live once and you just like let it rip. So one thing I've been wanting to do is get rid of never reset. So early on in CircuitPython, maybe I shouldn't talk about this right now. Early on CircuitPython history, I wanted to make it clear that when the VM's done, it resets everything back to the same state. And so one thing I added early on is this, like, regardless of what happened in Python, reset everything. So reset all the pins, reset all of the peripherals back to their known state, turn them off, blanket. But then came along this use, particularly for displays, where I said, hey, display, like, I want actually, when you set up a display in the VM, I want it to actually persist, because like we can show error messages on the display, and that's really useful. So then I added this concept of never reset, which is like we do this bulk reset, and then if it says never reset, we don't reset it, and it just turns more and more into a pain. And so this is something I just threw an LLM at. If you look at the commits, I was doing this on Wednesday when I was home with my sick kid. And I just said, hey, Claude, like, I want to remove never reset and just use Python finalizers. So what I found is in the last years, like, not only do I have to do the like bulk reset, but I still also need to make dinit on a particular object reset everything as well. Because the user may say, like, okay, I'm done with this, dinit it, and it should set everything back to its original state. And so you kind of have two ways that you're getting back to like the default state, and that's kind of annoying. And so the goal here is like, let's just get rid of the bulk reset and the need, and therefore also the need for this never reset. You make an object, it could live in the VM or outside the VM. You've constructed it, it grabs what it needs, and then it can live as long as it wants, until it's either manually dinit or it's dinit by like a finalizer, because like Python land is no longer using it. So I've got this working thing, and I think that's also part of, I should get back to the CircuitPython 2026's came in, because it was partly queued by one of them that came in. So why would the VM reset? So the VM resets if you change your code. So, sorry. Sneeze. So the VM, the way that CircuitPython works is that you have a drive, a fat file system with a code.py on it. So you start up and you run code.py, and then either like code.py will end and the VM just comes down and nothing happens, or what can also happen is that if you have a USB workflow, you get a CircuitPy drive and you can edit the file. And when you edit the file, it basically Control-C's the existing version of your file. It cleans everything up and then reruns the code.py. Yeah, sorry, I should figure out a sneeze button. I sneezed last week too. I hope it's not too loud for you. Yeah, so the VM resets like between runs of code.py. But then we've also had to do this like, so for displays, we have to do this release displays thing, which is ugly. So we had to teach people like, oh, like if you're doing displays, because displays live longer, they live outside the VM, you have to do this release displays before you try to create them again, because you'll like move on. So there's like all this work that I want to do around displays that is like intertwined with never reset. So I was like, let me just see how well, and I've glanced at it and I like did a couple build fixes to get things that like that the LLM missed fixed. So there's like still work to do there, but like it's done a bunch of files already, which was good. The Darsh asks, what do you guys do when objects fill up the usable RAM? We throw a memory error, just like regular CPython would. You've probably never seen it in CPython, but there is a memory, out of memory exception that we can throw. We will only throw that if we've like tried to make space in the GC, or we've tried to garbage collect and we haven't been able to find space. We'll raise a Python exception. And this also is like in CircuitPython 10, we basically have this dual heap model where we have a long-lived outer heap and then we have the VM heaps within that space. So it's not super, I know it's been kind of confusing to people, but now we can have things. The advantage of that is we can allocate things outside of the VM heap that are allowed to live longer, which is good. So for this IO expander stuff, for example, because a display is using it that I'm initializing, I'm allocating the IO expander outside of the Python VM, which means it won't be free. It wouldn't be freed unless it was explicitly freed. Which it doesn't, because it's like part of the board and we just want to leave it active. All right. Deep dives are only usually, they used to be 2 hours, but we're going to try to only do an hour again. So let's go back to the CircuitPython 2026 stuff. Maybe next week I'll do some Claude coding. We'll see where I'm at the end of next week. 3 more. So I don't think I did these. These are the start of the week, right? So Retired Wizard said improved home automation network support. So Thread and Zigbee, although Zigbee is quite low on our list, but Thread I think might happen. Easier board adoption with Zephyr, like we're trying to get there. Last week I think I was showing, at the end of the time I was trying to show like bringing up a new board. I actually have that. I did get that board, the NXP RW612 I did get. And then Edge AI neural net experimentation, not high on my list. I've still not seen a great example of that. What are the ways a person could add Wi-Fi to an RP2040 system without an espressive coprocessor? I mean, I would use an expressive coast processor. There is also the RM2, which is what's used on the Pico W. But no, you need a coprocessor of some sort. There are other Wi-Fi coprocessors that you could look at. RM2, Nordic has their NRF 7002. You would probably want to do like the CircuitPython Zephyr port at that point, because it's got better Wi-Fi coprocessor support if you want to be non-ESP. Okay, so that's what Retired Wizard said. Deshipu makes these like cool quadruped robots, Pew Pew game console, and micro game consoles. If you don't know, Deshipu is like one of the OG users of CircuitPython and Micropython. So was trying to get audio, like voice synthesis working, but it didn't quite work out. Deshipu was here earlier. I would be curious to see if you could have have an LLM help you with these tasks. Looking at a different chip, some CH32. I would definitely look at like the Zephyr support for any new chip that you're looking at, if we don't support it already. S3 is great. New games are always welcome. The FruitJam is a great platform for games. I think that's really the highlight of 2025. Fewer bugs. Yeah, I think fewer bugs is like a testing problem. Like we need to be better, a bit more rigorous, and it's not my strong suit. But I really need to, like, given how much code can be created, being a little more rigorous is something I want to try being this year. Async support I think would be cool too, and that's actually like async support is potentially, you could say, like, figure out what the pattern you want for it. So like if you want async spy, like figure out how to do it, and then just like once you figure out how to do it, you could apply it across more things pretty easily using an LLM. So yeah, there's a lot of things that are made easier by this, like figure out the pattern, give an example, and then apply it more broadly. What are the ways, I've seen those SDIO Wi-Fi modules. Do you have any idea about their interface? Generally, SDIO you could do as like a single bit, and then it's basically SPI. But again, I would just look at the Zephyr source. Last year we made good progress on writing games. MIDI has some rough edges. I think there's been discussion of native USB MIDI support so that CircuitPython could do more buffering and processing in C. I think that would be great. Audio with SynthIO is great as well. Better support for long samples. I'm very excited for trying SynthIO and the audio stuff in the Zephyr port, because Zephyr actually has threads, and so you could actually like do a better job keeping up, I think, in that case. Although their I2S support is not very well tested. Higher frame rates for graphics. Yeah, another kind of thing that I would like to do at some point is display I/O on top of LVGL, not on all my custom code for display I/O. I think that would be the way to go for the future. LVGL is super popular. It also has an interface for like accelerators on chips. Like the higher end chips have like these like 2D DMAs or like other things that could do mixing and stuff. So I don't want to interface with those directly. I think I'd rather figure out how to build display I/O on top of LVGL for those. Sam also says they're attempting implementing some Zephyr drivers and a board def for the Dao chip. Dao, something like that, which would be great. That's Bunny Wong's new chip that he's announced, and there's a crowd supply for. Looks pretty neat. I'm excited for that too, and like the way that we're attacking with CircuitPython is that like we only really want to do a new chip if it's supported by Zephyr, because you get like Flash and compiler flags and a bunch of stuff for free. Plus, we want to move to a world where we have an RTOS. And educational apps, which would be cool. So those are those three. And the other three were Dan, Anne, and Dana, I think. That's probably how you say it. So Dan says, I love QSpy displays like this one to work in CircuitPython. Yes, I have one. I haven't looked into it enough to know how good that would be. What are the use cases of triple buffering? I do not know. I don't know graphics that well. That's where you come in. Let's see what Ann says. Full support of the ESP32P4. That's definitely going to be true, and I will probably, when we get closer to releasing Adafruit hardware with the P4, I will probably cycle back to making sure that everything's hunky-dory there. That's an also good opportunity for us to come up with some like test harnesses sorts of stuff. Beata says, I would not mind not having to poll for buttons. I think like the keypad stuff should be able to help you with that. I think you could just direct connect into keypad, and then keypad can give you events. But I think maybe you're getting it like async IO sort of awaiting. That would be awesome too. Yeah, and I guess I had this fantasy that like the async IO stuff could like tie back into an RTOS, which would be kind of cool. Yeah, maybe somebody else knows why you would do triple buffering, but I do not. Graphics is not my strong suit, for sure. Early adoption of any new Raspberry Pi microcontrollers is also crucial. I agree. Circuit matter, I think so too. I think we need to get that across the finish line. Like I got it working reasonably well on CPython and Raspberry Pis, but we don't have all of the cryptography stuff we need in CircuitPython, so that's definitely on a to-do. Anne says VGA and composite video modes on RP2350. I will tell you, I will not be doing that. I'm just like, I don't think that many people have those monitors anymore. I'm much more keen on DVI or HDMI. That is to say, if somebody wants to add it anyway, I would be happy to merge it. The documentation continue to get even better. I agree. Anne's a big part of making the docs better. Talking about MCU graphics here, not on desktop. I mean, you're lucky if you can get 2 buffers. I know that like for our HSTX stuff, it's just 1 buffer. It's not even 2 buffers. But these, sorry. Dan and Ann we did, and then Dana says, I think it would be useful if CircuitPython supported 2 or more displays at the same time. Multiple Nuke CTFT displays, or FruitJam and something else. Sorry for the sneezes. I agree. And I asked, like, do you think the terminal has to be on all of them? And no. So there is an issue, I think I linked to it here, where I've talked about this. So this gets back into the never reset stuff. And if I had more time, I might take a stab at actually making this happen. I did get out this board, which is a lilygo board, and it's got 4 displays. Yeah, DCD says, maybe there are some Adafruit keyboard tools that one could build a sneeze mute button. Yeah, it is interesting. I guess I only have one place I would need to mute. I would just need to mute OBS. I'm used to doing the community meeting, and in that case, there's 2 places that need to mute. But this is a device I'd actually love to get going, because I have an issue where I can't remember what keys do, especially in a macropad. So if I had a macropad that had a screen in every key, I would know which one had a sneeze emoji on it that I can press when I want to do it. So this is the one I was like, oh, it'd be cool to get this going if I could actually do more than. So right now you can hard code how many displays you want to do. But yeah, I want to get away from that. So I think what I'm thinking is that all displays would be allocated off the heap. But we would have a way of knowing, like, if they were alive in the Python VM and which one was like designated for the terminal. And then you could only designate terminal ones if like its dependent buses are like allocated outside the VM as well. So yeah, stuff like that to think about for it. Yeah, so I would like multiple displays and this like never reset stuff. I would love to do. It's in that category where it's like it's like so much manual editing. I don't think I would do it on my own, but like because I already have a draft and that I can like try to poke and get working and then test it, I think it makes it much more feasible as a thing to do. Any other questions? We're just about out of time. I don't really want to get started on anything else, although I will actually be working for a little while longer. Oh, I know. Let's take a look at Tim's. So Tim, aka Foamyguy, did send their CircuitPython 2026, but I have not posted it yet. So let's just take a look in the last few minutes here. So Tim emailed the CircuitPython 2026 at adafruit.com and says, I accomplished many of the things I mentioned in my 2025 post. A few that stand out are adding tile palette mapper and getting a much better understanding of register-based drivers, both which allowed me to learn a ton. I also really enjoyed working on FruitJam OS and the games and programs that run inside of it. Looking forward to 2026. Here we go. A few things at the top of my mind going into this year are MIDI and RAG, Retrieval Augmented Generation based AI tools. RAG is a technique for getting better, more specific and accurate results from LLMs about specific topics by looking up key pieces of information to give context. I looked into this and built a basic proof of concept that ingests the examples from the library bundle and begun the process of pulling in stubs from the core. Definitely want to pick this effort up and continue experiments with locally run models. I'm curious to see how good of output is possible for CircuitPython specific questions with local models that can run on reasonable hardware. I think that's an awesome goal, getting stuff like that running locally. Tim also says, MIDI is on my mind because I recently got a MIDI controller and have been playing with it a lot using CPython and libraries and CircuitPython with synth.io. Till now, I have not played much with MIDI or synth.io, and it's been great fun so far. I'm looking forward to diving further into them this year. Continuing from last year, I'm always looking out for opportunities to improve display.io and create new widgets and functionality. Several of my projects this year led to new display.io libraries and expanding functionality in existing ones. Is it possible to run LLMs on common MCUs? I don't think so. Not... Like, I was looking at it, I was like, can I run, I guess I was looking at Whisper, which is speech-to-text translation, and I was like, can I run that on a Raspberry Pi? And it was like, maybe not. There are people trying to run, like, very small models on microcontrollers, but they're, like, very specific task-oriented things. In fact, there's somebody, we blogged it up and they were on the Discord, who was running a model, I forget what they were running it on, but it was like a model that was designed to classify handwritten numbers, So like being able to like recognize a 1 or a 2 or a 3 or a 4 or a 5, doing that on a microcontroller. But to say like a large language model is on an MCU is not going to happen. Doesn't mean that you can't use them as like a bridge to it. So like doing API calls to one via like an S3 Wi-Fi, but running it locally on there is not going to happen right now. A lot of the new microcontrollers claim to have neural net accelerators on them. Retired Wizard says there's a playground. But it's quite limited. Home hub. Water flow sensor. Moon miner. I should look through this more often. Ooh, rest on it. So this is a like project site that anybody can post to that's run by Adafruit. That's kind of cool. It's kind of like, it's like, I'm sure it's based on the learned code. But touchscreen pager and tracker. Huh. IRC bot. The doctor will see you now. A chat bot nobody needs. Yeah, lots of cool stuff here. Beyond the print statement. We need Adafruit product suppliers in Egypt. I would take a look at DigiKey. Like DigiKey ships a lot of places. You could also, if you can make PCBs, you can make them yourself. Just don't sell them as proper Adafruit products. All right, I don't see any other questions. Yep, Yanni points out that DigiKey delivers a lot of places. All right, I'm gonna wrap up, stick to my hour. I'll be on the Discords. Monday is a holiday in the US, so I won't be on the Discord on Monday. But if you have been inspired to do a CircuitPython 2026, take a look. Post it somewhere, email circuitpython2026@adafruit.com. I'm going to do the last post for that on Wednesday of next week after our Tuesday meeting with the final call on Tuesday. Thank you all for hanging out. I hope I didn't turn anybody off by being like, LLMs are great, which they are if you know when to use them. I should be around next week, I think. And you can find me on the Discords. You want to join the Discord, the URL is adafru.it/discord. If you want to support me and Adafruit who pay me, you can go to adafruit.com, purchase hardware there. We're going to start to get rolling in the new year, get some new stuff out here in the next few months. And we'll make sure the software is up to snuff. If you want to follow the Yoto player stuff, you can buy those off Amazon. They're like, the mini's like $80 and the big one is 110. So if you want to burn that money until, well, the original thing is cool too, but we're hoping to run CircuitPython on those two things too. And then I was thinking about, I was like, it'd be cool to do like a podcast player. I'm gonna get this.